Alright, so we're going to do lesson 65, prime factorization, division by primes, and factor trees. I've got about 4 pages here, but as you can see, I wrote pretty big, and I added a little extra information. So first thing I want to do, this page right here, this is all just talking about definitions that you should already know, or that are brand new. So first thing, prime number. You definitely know this one already. But just in case you forgot, or just in case you misremember, I'm going to go over it again. So a prime number has only 2 factors, 1 and itself. So if I were to ask, what are the factors of 5? The only 2 whole numbers you could tell me that multiply to give you 5 are 1 and 5. So I would do my little factor thing, and then I would do 1 times 5. Can 2 work? 2 times 2 is 4. 2 times 3 is 6. Oh, nope, I missed 5. Okay, 3. 3 times 2 is 6. 3 times 1, nope, it's no good. 4. 4 times 1 is 4. 4 times 2 is 8. Nope, these are the only 2 numbers that work. If I want to try a different number, let's see, what's another prime number? I believe 23 is prime. Let's check it. So 23. If I make my little factor thing, I'm going to start with 1 times 23. Does 2 work? No, because it's not even. 3. 2 plus 3 is 5. 5 is not divisible by 3, so 23, also not divisible by 3. I can automatically cross out 4, 6, 8, 10, 12. I can cross out all those numbers because I know they don't work because they're all even numbers. So let's see, 5, I know that one doesn't work because it does not end in 5 or 0. Let's see, 7, 9, 11. Okay, so 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. I skipped 23. 9 is divisible by 3. This number is not divisible by 3. 9 doesn't work either. 11, let's see. 11 times 2 is 22. 11 times 3 is 33. 11 does not work. The next number would be 13 that I would try. 13 times 2 is 26. Any other number that I try, the smallest number I can multiply it's 2, and they'll all be bigger than 23, which means my only 2 numbers are 1 and 23. So 23 is a prime number. Okay, composite number. A composite number is composed of, if you know from music, a composer is someone who writes music. A composition is something that is created or made up. So a composite number is made up of or has more than 2 factors. So for example, the number 4. It has factors 1, 2, and 4. So it has 3 factors. It is a composite number. Example, the number 20. The factors are 1, 2, 4, 5, 10, and 20. So 1 times 20 gives you 20. 2 times 10 gives you 20. 4 times 5 gives you 20. So there are 1, 2, 3, 4, 5, 6 factors. It is a composite number. Okay, so every single whole number in the whole entire world from that is greater than 1, so every number 2, 3, 4, 500, 3,712 can be called a prime or a composite number. Once you start getting into those bigger numbers, it's more likely that it's a composite number. But there are some pretty big prime numbers out there. So any composite number can be formed as the product of multiplying prime numbers together. So let's talk about that in a little bit. But like this one right here, 20, I have 1, 2, 4, 5, 10, and 20. I could actually say that if I take 2, which is a prime number, times 10, so 2 times 5, equals 20. So this is actually 4 times 5 equals 20. But I broke it down into a prime number times a prime number times a prime number equals 20. So we're going to learn about that today. All right, factorization. The verb, or the action word, for breaking down numbers into factors is called factorization. So for example, 20 is equal to 1 times 20, or 2 times 10, or 4 times 5. There are 6 factors. When I do prime factorization, if you break down a number into its prime number factors, this is called prime factorization. For example, 20, as I did up there, is 2 times 2 times 5. All 3 of these are prime numbers, and they are prime factors because they are numbers that are being multiplied to give me a product. There are 3 prime factors for 20. Okay, it'll make a little more sense once we start actually using it. So one method of factoring into the primes is division by primes. So in order to factor a number using division by primes, we write the number in a division problem, and then we start dividing by the smallest prime number. Some common small prime numbers are 2. You can use that on any even product. So if you have any even number, if your number ends in 2, 4, 6, or 8, or 0, you can divide by 2. Another small prime number is 3. If the number is divisible by 3, and remember the check for divisible by 3 is you take all the digits in the product, add them together. If that number is divisible by 3, then the whole number is divisible by 3. Okay, the next common small prime number is 5. You can use this anytime the number ends in 5. So I'm not using the normal divisibility rule for 5, which would say 0 or 5, because if it ends in 0, it's even, so I would use 2 instead. And then I would come to the 5 later. So 5 is the smallest prime number for any number that ends in 5. 7 would be a good one to try if your other primes don't work. It's not really going to be always the case, but if you've tried 2, 3, and 5, 7 might be a good fit. Alright, so how to use division by primes and find your prime factors. So we're going to use division by primes to find the prime factors of 60. You'll start with 60 divided by 2, because it's an even number, and 2 is the smallest prime factor. So we set it up 60 divided by 2, because 2 is our small prime factor. 6 divided by 2 is 3. 3 times 2 is 6. 6 minus 6 is 0. We're going to bring down this 0. 0 times 2 gives me 0. So 2 times 30. So now we're going to divide our quotient of 30 by 2, because we still have an even number. So we still need to divide by the smallest prime. So 30 divided by 2, we're going to get 15. So our new quotient is 15. So now we'll divide by 3, since the number is no longer even, and 3 is the smallest prime factor. So it does end in 5, which means 5 is probably going to be in there. And honestly, 5 is a prime. We could divide by that next. But the book wants us to use the smallest prime number each time. So we're going to use the 3 because it's smaller than the 5. So 15 divided by 3 equals 5. So we're going to stop because we've came up to just a prime number at the end. So the last step is we're going to take each of these prime numbers that we came up with, all of our divisors, and our final quotient, and turn them into a multiplication product. The prime factors of 60 are 2 times 2 times 3 times 5. All 4 of those numbers are prime. Check. And if I take 2 times 2, I get 4. 3 times 5 is 15. 4 times 15 equals 60. So we're good to go. Okay, so example number 1. I'm going to fold this up. Okay, so the first example from the book. Use division by primes to find the prime factorization of 36. So we start with 36. It's an even number. Our smallest prime is 2. So divided by 2. 2 times 18 would give me 36. Okay, so I take 18, I move it into the next problem. 18 is still even, so I'm going to divide by 2 again. 18 divided by 2 is 9. Oh, we're not even anymore, we're getting closer. So I'm going to take this quotient, 9, divide it by my smallest prime, 3, and I get 3 times 3 is 9. So now I'm going to take all these numbers, 2, 2, 3, and 3. 2 times 2 times 3 times 3 equals 36. So if I want to check all prime, yes, 2 is prime, 2 is prime, 3 is prime, 3 is prime. Correct product. Well, 2 times 2 is 4. 3 times 3 is 9. 4 times 9 equals 36. So yes, we're good to go. All right, so now I'm going to talk about factor trees. These are kind of fun. I like factor trees. They look cool. They're like this little branching thing. It's really more of factor roots because it's going down, and I don't know of very many trees that grow downward, but their roots definitely grow downward. So factor roots, or factor trees, are a visual way to find prime factorization. It can also be used when finding roots later in math. I didn't make that connection until just now. So roots, I know for 5B I got a chance to touch on squares, but I did not get a chance to teach anything about that to 5E. But if I had a number like 5 squared, that means 5 times 5, which is 25. If I were to go backwards and make a factor tree out of 25, it would be 5 times 5. My square root would be 5. So I make my roots, whatever number I get 2 of the same, because my exponent was 2, it's the same thing. So anyway, you will learn more about that, hopefully in 6th grade, very likely in future years in middle school. So instead of always starting with the smallest prime factor, you can start with your favorite factor or an easy one. It doesn't even have to be prime. So, how to make a factor tree. Let's make a factor tree for 60. The number ends in 0, so we know 10 is a factor. Let's start there. So 60 is equal to 10 times 6. So we write this in a stacked way where the factors branch out diagonally like a tree. So I write my 60, and then I do a tree branch, and I do 10 times 6. You don't really have to write that multiplication sign in there, but I put it in there anyway just because it's good to kind of have that visual reminder. So 10 times 6. For the next level, we need to factor 10 and 6. 10 can be factored into 2 times 5, or 5 times 2. And 6 can be factored into 2 times 3. Okay, so I draw my branch, 5 times 2. Draw my branch, 2 times 3. So notice, if I were to cover up this side, I'm only looking at my 10, I'm looking at my 5 and my 2. If I only look at this side, I've got my 6, and it branches down to 2 times 3. So right now we have only prime factors, so we stop. But if we had any composite factors at the bottom of the tree, we would keep on going. So we're going to do an example like that next. Okay, so I'm going to move on. So remember, 60. You pick your first starting numbers unless the problem tells you what to start with. 6 times 10, because we end in 0. It's easy, right? And then you just break it down into the smallest possible numbers. until you can't get any smaller. Okay, example number 2. Use a factor tree to find the prime factors of 60, and it tells us to start with 15 and 4. So, branch, 15 and 4. 4 breaks down into 2 times 2. 15 breaks down to 3 times 5. So 60 is 15 times 4. 15 is 3 times 5. 4 is 2 times 2. Okay, so I just wrote those on the side to remind you. You do not have to write this. This is just extra, hey, this is what we're representing in our little tree right here. Okay, example number 3. Use a factor tree to find the factors of 60. This time, start with 3 and 20. So, we know that 60 is 3 times 20. 3 is already a prime number. We do not have to branch off anymore. So 3 is done. Just stop right there on the 3. 20 is not done. 20 is a composite number. So, let's think of more numbers. We could do 10 times 2. We can do 4 times 5. I'm going to go with 4 times 5. So 4 times 5 is 20. 5 is a prime number. So I can stop on that 5. It's done. Leave it alone. But 4 is composite, so we need to break it down. 4 is 2 times 2. So now I have prime, 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 and I have no more branches left, so I'm done. So in this case, the tree stops branching when you find a prime factor. Your prime factors will be the last numbers in a branch. So I would write it out as 5 times 2 times 2 times 3. Or I could write it in order of size 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. As long as I only use each number once. So every end of the branch can only be in there once, but the matter does not order. I meant to say the order does not matter. Alright, so I'm going to move on to the lesson practice. And we're at about 17 minutes for that lesson. It would have been faster to watch the online one, so whichever one you like better. Alright, so classifying. Which of these numbers are composite numbers? Which means they have 3 or more factors. Well, the way to solve it, let's start with 20 because we already know that one. 20, its factors are 1, 20, 2, 10, 4, and 5. So this one is a composite number. Think about your other numbers. What numbers multiply to give you 19? What numbers multiply to give you 21? What numbers multiply to give you 22? I'll give you a hint, it's even. What numbers multiply to give you 23? So give me a list of all the numbers. I think there's going to be 3 of them. All the numbers that are composite. Okay, so don't tell me the primes, only tell me the composites. Write the prime factorization of each composite number in problem A. So, we already did 20, so I'm going to say the prime factorization. Oh, ooh, okay. I got you. I see where you're coming from. So it's not going to be 1, 2, 4, 5, 10, 20. No, those are just the factors of 20. I want the prime factorization. So you can use your factor tree or your division by primes. 20 is 2 times 10. 10 is 2 times 5. So 20 is 2 times 2 times 5. And then do all the prime factorizations for the other numbers as well. Okay, use a factor tree to find the prime factorization of 36. So you're going to start with 36. Pick 2 numbers. If you're working on this on the computer, erase the question mark and put in your number. So 36 and 1. This is not the correct answer. 1 times 36 is not going to help you at all because you went from 36 to 36. You're just going to be sitting here 1 times 36, 1 times 36. Don't use that number. Okay? So you pick your 2 numbers to start with. erase my question marks and fill them in. Or if you're doing this at home, then just put in your numbers. Let's say you did 6 times 6. What other numbers work? 9 times 4 works. So pick your favorite, whichever one you want to work with, and then get it down to its prime factors. Okay. Use division by primes to find the prime factorization of 48. Well, I'll get you started on this one. 48 is an even number, so I can divide by 2. 2 goes into 4 2 times. 2 times 2 is 4. Bring down the 8. 2 goes into 8 4 times. Minus 8 is 0, so 24. Then I'm going to have 24. It's an even number, so I'm going to divide by 2. And just keep going until you run out of divisions, until you have all prime numbers. Then you're going to have your 2 times 2 times whatever other divisors you have, and your final prime quotient. Write 125 as a product of prime factors. So you're going to pick your favorite method, either the factor tree or the division by primes, and you're just going to go at it. So if you're doing the factor tree, think of your numbers that could work. Well, it ends in 5. You could start with a 5 times something. Or maybe you recognize that if you had quarters, so money, 25, 50, 75, $1, $1.25, maybe you recognize that 25 is a factor of 125. And if you have 5 quarters, you have 125. So maybe that's what you want to start with. It's not even, so 2 is not going to work. 1 plus 2 is 3. 3 plus 5 is 8, so 3 is not going to work. 5 is your smallest prime. So you can either start with the factor tree, or you can do your division by primes, however you want to make it work. So I'm going to let you guys finish that. If you need more help, please find me on Zoom. My hours Monday, Wednesday, and Friday, I have morning hours from 10 to 11. I have afternoon hours on Tuesday, Wednesday, Thursday, and Friday from 4 till 5. And I have a special Monday hour from 2 to 3. I do not have a 4 to 5 on Monday. So please find me if you need help. Continue to watch more videos on YouTube if you need help from other teachers who have different styles and have maybe some more experience with math teaching than I do. I do a lot of tutoring for math, but not so much on the initial first time teaching it. So I hope you guys are having a great day, and thanks for spending your time with me.